So basically what we are going to learn is how to identify the fundamental frequency in a signal when you have an audio file. So let me start by playing you the audio file. Uh, Here you would see that this is the audio file. And this is a recording for my DSP class. Hi, my name is Shadeeb Hussain. Okay, so you heard the audio file, uh, but the thing is, it has a lot of frequencies. There would be a lot of harmonics in this signal, right? And you, as an engineer, want to identify the fundamental frequency in the signal. So how am I supposed to do that? The first step, so let me first run it and show you what exactly is happening. You would find that there would be a lot of signals, like as you're speaking through, you will find a lot of frequencies over there and a lot of harmonics over there. But there is a fundamental frequency in the speech segment, and you're trying to identify that fundamental frequency. So the first step would be to load the signal, and that is done by using audio read, and that was the wave file that we had. You're trying to get the signal and the sampling frequency. Once we did that, we tried to get the fast Fourier transform. Now, FFT in MATLAB helps you to identify the frequency. It converts the time domain signal into the frequency domain signal. Now, when you're plotting it against the frequency, you have to make sure that the vector size is equivalent to the y. So this is the steps that you would do uh, in order to identify, so making sure that the vectors are of the same size. Uh, Once you have done that, then you try to plot it. So when you plot it, you're trying to plot the y, which is the Fourier transform, against the frequencies. Now this was what, now when you run this, this is the first portion of the signal. Okay, so you would see as you speech, for your speech, you will find that it is consistent of a lot of frequencies over there. But you would find that most of the signals are concentrated in a particular frequency domain. In this case, like for this one, if this is the center, 0, and if you're taking over here, you will find that most of the signals are concentrated over here, and it's just a mirror reflection of this one. So what I try to do is I try to zoom in over here. Okay, so I'm just limiting my x-axis between these to identify what frequencies are there. Once you did that, you would be able to find that it has a lot of signals in it, but that is not a very good way to identify what's the fundamental frequency. Okay, so in order to do that, that's where we use fftshift function in MATLAB. Remember, this is the function that you would be needing in order to identify that fundamental frequency. So since I showed you earlier that, let me just bring back the, uh, let me run it again. So you find that most of the frequencies are in this range, right? So that's why what I did was I started the frequency with 10K, and then the signal is 15K. You're trying to find the 50, you are trying to find the fast Fourier transform of this segment and using FFT shift. Okay, so you have to use FFT shift and you have to basically find the Fourier transform of that one. Next is the same as the previous one, that we tried to find out the vector length, making sure that the vectors are of the same size. And then when we are trying to plot it, you would find that it has a fundamental frequencies. Okay, now you would see that over here it is at 124.958 hertz. That means around, you could say it's around 125 hertz. So the fundamental frequency in this case is 125 hertz. Okay, so you just can't depend on fast Fourier transform to identify the frequency domain. You have to do the FFT shift. Now what does FFT shift do? if you go to the MATLAB file, it says over here very clearly, it helps you to rearrange a Fourier transform X by shifting the zero frequency component to the center of the array. Okay, so you basically have to rearrange the Fourier transform by shifting the zero frequency component. So that is very important in order to find the fundamental frequencies.